Hello, welcome to Prajim Technologies. I am Venkat. This is part 40, Exception Handling. In this session, we will learn the basics of exception handling. Let's look at an example. I want you to write a C# program which can read the contents of a text file and display them in the console window. Now, in my C drive, I have a folder called sample file. So if you look at this path in C drive sample files folder, I have a file called data.txt. And if I open this notepad, you see that we have a message, welcome to online C# training from Prajim Technologies. Now I want you to write a C# program which can read the contents of this file and print them onto the console. And it's very easy to do that. So let's get back to Visual Studio. Now, if you want to read or write to a file, then we have to make use of classes that are present in the system.io namespace input output. So let's go ahead and import that using system.io. Now, within the system.io namespace, there is a class called StreamReader class. What this class basically does is goes out to the file and then reads the contents of that file and then streams them out for us. So let's say StreamReader. Let's create an instance of that class. StreamReader is equal to new StreamReader. And if you look at the constructor of the StreamReader, it expects the path of the file whose contents you want to read. Okay, and we know that in C drive sample files folder, we have a file called data.txt. So we want to read the contents of that file. So let's go ahead and put that. So the name of the file is data.txt. Okay, so this is the constructor expecting, and obviously you have a red squiggly here because a backslash has special meaning. It's an escape sequence character, so you need to escape that with another backslash, or you can use the verbatim literal. Whichever you choose. Here for the valid Windows path, the verbatim literal looks good. So let's go ahead and use that. So now what we are doing here, we created a StreamReader class which goes ahead and reads the contents of this file. And what we want to do is read the contents to the end of the file. And if you look at the return type of this method, it's a string, so we can print that directly onto the console screen. So we pass this entire content onto the console screen, and this will go ahead and print that. All right, and finally we need to close the StreamReader. Okay, what this close statement does, if you look at the IntelliSense, it closes the same StreamReader object and the underlying stream and releases any system resources, any system resources to which this class is holding on to during the program execution. Those will be released, when we call this close method. Okay, let's go ahead and run this. Now, when I run this, you expect this output. Welcome to online C# training from Prajim Technologies, which is present in the notepad. Your program has read that and print that out onto the console. Now, everything is fine. You have the file, you ran the program, everything is fine. Then why do we need exception handling? Now, what is an exception? An exception is nothing but an unforeseen error that happens when your program is executing. Let's say somebody goes and changes the name of that file, or somebody deletes that file. What happens when this program tries to read that file? It will throw an error because that is unexpected. You always expect that file to be there, but somebody changed the name of it or somebody deleted it. So it's an unexpected, unforeseen error. But your program should still be in a position to handle even those kind of unforeseen errors. And that's where exception handling comes in. Okay, now let's go ahead and actually change the name of that file. So let's say, for example, somebody just came here, they changed the name of the file from data to onedata.txt. Now if we run this program, look at what's going to happen. We have an unhandled exception. And if you look at the exception, it is a file not found exception. Okay, so what this program did, it tried to read the contents of this file, but in this C drive sample files directory, there is no file called data.txt, and the system threw an exception saying that, okay, I cannot find that file anymore. Okay, now if your end users looks at this message, okay, unhandled exception system.io file not found exception. If you're not from a .NET background, obviously your end users will not know anything about .NET. So when they look at this message, it doesn't really make any sense to them. So to our end users, we should actually be giving, useful messages. Now, what are the problems of not handling exceptions? Actually, there are several. And the first and foremost is that your end users will see this confusing and cryptic message which does not make any sense at all. So they will definitely be annoyed by looking at messages like this, and they will never come back to use your program again. And the next most dangerous disadvantage of unhandled exception is that, you know, this exception information contains valuable, information to a hacker. Okay, the hacker can use this information to actually hack into your application. Actually, when we talk about ADO.NET, in that session we will learn how to use exception information to hack into an application. But just until then, believe me, exception information can be used by hacker to hack into your application. So that's another disadvantage of not handling exceptions. Okay, and from an application perspective, another problem is, look at this, it tries to read this, it tries to open this file and read the contents of this file, this particular line. Okay, now at this line we got an exception. So when that happens, what will basically happen is these two lines will be skipped and your stream reader will never be closed. So your resources, if you don't close the stream reader, the resources to which this class object is holding on to is never released. you know that's why it's always good to use exception handling. Okay, so what is an exception? An exception is an unforeseen error that occurs when a program is running. We have seen a very simple example, a program trying to read a file, and if the file is not found, the program throws file not found exception. Similarly, if your program tries to read from a database table, and if the table does not exist, or if the database is down, or if you have misspelled a column name, then there will be a SQL exception. Okay, however, these are very unlikely, but you still should anticipate them, and your program should be programmed, basically to handle exceptional situations as well. And that's where exception handling comes in. And we also have seen, if you don't handle exceptions, users will be annoyed as the messages they see are cryptic and doesn't make any sense to them. And exceptions contain information that can be used for hacking into your application. And what is an exception? An exception is not something strange. It is actually an object, you know, that is derived from system.exception class. Let's look at that in an example. Now, to handle exceptions, we use a construct called try, catch, finally. Okay, so try. So in the try block, you will put the code which can possibly throw an exception. Okay, so any line within this try block, if it throws an exception, what will happen is, let's say for example at this line there is an exception. Immediately what happens is the compiler, the runtime, will skip executing these two lines, and the control will be, you know jumping to the nearest catch block, in this case this catch block. So these two lines will be skipped, and then it comes into the catch block. Let's say for example I want to catch an exception, so let's say EX. Okay, so we are catching that exception. Now if you look at this exception object, if I right click on that and when I say go to definition, you will actually find this is nothing but a class called exception. Okay, and if you look at this class, it has got several properties. For example, message, source, stack trace, targets height, etc. We'll actually be investigating what these properties are and what is the benefit of them. Okay, so now we have this exception object. So when there is an exception, what happens? It immediately jumps into the catch block, and this exception object receives, that exception. And then you can basically use the properties. Let's say, for example, I want to know what is the message. You can say ex dot message. Okay, and similarly, let's say, for example, I want to print the message console.writeLine ex.message. Similarly, if you want to look at the stack trace, let's go ahead and write that console.writeLine x.stack trace. And just to kind of have some space between them, let's have a couple of console.writelines. Okay, so now if you look at this program, we are actually inspecting the message property and the stack trace property. So if we run this program now, look at this, it's in the debug mode. What it is trying to do, it's trying to create a stream reader class. The moment I do that, it tries to create the class object, and then it tries to read that file which does not exist, and there is an exception. So when we press F10, and if you look at this object, look at this, there is actually a system.io.filenotfound exception. Interesting. This object reference variable, if you look at this is of type exception, but if you look at the actual object that is thrown, it is system.io.filenotfound exception. Okay, we'll come back to that in just a bit, but now if you look at the message, the message property will give you a meaningful message about the exception. Okay, it's saying could not find file, whatever, C:\sample files data. Similarly, you have the stack trace property. If you look at the stack trace property, what will the stack trace property give you? It will actually tell you which line in this program is actually throwing that exception. So if you look at this in program.cs file at line number 10, there is an exception. Okay, so if I close this and come to this program, and when I say Control G and line number 10, so it comes to this line. So obviously we have this exception here. So stack trace property will give you, the line number where actually the program has caused an exception. The message property will give you a meaningful message about that particular exception. Okay, so if we let this through, and we have seen that actually the object that is thrown is a file not found object. Okay, so what is that file not found? Let's go ahead and say, instead of this one, we'll actually use file not found. So catch file not found exception, let's say EX. Okay, so now let me go ahead and right click on that. Look at this file not found exception. Okay, this class is inheriting from IO exception, and if I right click on that one and say go to definition, IO exception inherits from system exception, which in turn inherits from exception class. So what I mean to say here is, for all the exceptions within the .NET Runtime environment, within .NET Framework, they directly or indirectly inherit from the exception class. And if you look at this exception class, it has got the message, stack trace, source, target site, etc. All these properties are really valuable in order to debug and figure out the issue. So since any exception, there are several exceptions in .NET. Actually, if you press Alt Control E in Visual Studio, it will actually show you all the exceptions that are available in .NET Framework. And so basically if you look at CLR exceptions, for example, and if you look at system, there are so many exceptions. Okay, argument exception, arithmetic exception. Okay, several exceptions are here. Now, any type of exception, directly or indirectly inherits from system.exception class. So system.exception class is the base class for all the exceptions that we have. Okay, so since all these classes are actually inheriting from system.exception, we know that they are going to contain all these properties as well: message, source, stack trace, etc. Okay, so let's go back to our program now. File not found exception. Now if I go ahead and run this, you'll actually see that, okay, this is the message and this is the stack trace information. It's very much similar. Okay, now file not found exception is actually inheriting indirectly from exception class. Now when you look at this file not found exception object, ex dot, apart from the regular things like message, stack trace, source, etc., there is another property called file name. Since this is a file not found exception, so there is a specific property on this object called file name, which will give you the information about the file which is basically not found. But whereas if it is a general exception class, it will not have this file name property, because uh, the base exception class is very generic. And this file not found exception is actually a child of that class, so it's specialized. In part 21 inheritance series, we have actually learned that a child class is basically a specialization of its parent class. Okay, now let's say, I mean, what you basically do is when you handle exception, you don't show this kind of messages to the end user. You use this message, stack trace, and whatever properties, and you write them either to a database, or you send an email to an administrator who will come and look at the exception and see how to solve that. Okay, but what you will actually do after you log the exception details or email them, you will actually print out a meaningful message to the user. For example, I want to say, please check if the file exists. And which file is that? You can say ex dot file name, because that property of this exception object will contain the file name which is not found. So if we run this now, you should see that please check if the file c:/sample files data.txt exists. Okay, so users are now getting a meaningful message, and you are handling exceptions, and basically above this line you may log the details to the database or event view or whatever for debugging purposes later. Okay, now let's do a simple change here. Now let me change this file name back to data, and if we run our program now, it will succeed. But now let's make a simple change. Instead of sample files, let's say somebody changed the name of the folder itself from sample files to sample files 1. Now I think since the program is using that, or let's change it here, sample1 files. Okay, now for some reason the directory name is changed. Now if I run this program, look at this, it tries to go to that path and read that file, but that path does not exist, meaning sample1 files directory is not present at all. So now when I press F10, look at this, there is an exception, directory not found exception. And if I let this through, okay, let me run this once again. So when I run this, look at this, I have a catch block to actually handle the exception. But this catch block can only catch file not found exception. But what type of exception did we get now? We get a directory not found exception. So obviously this catch block will not be able to handle that exception, because this is a different object reference variable, and what object is actually this program throwing is a directory not found exception. So obviously this ex reference variable will not be able to catch that. Okay, so for these purposes, there can be a variety of different exceptions depending on what your program is trying to do, and it may not practically be possible to remember all the type of exceptions. So in general, what we do is most of the specific exceptions that we can think of, we will include them, and just to be safe, we will also include another catch block where we specify the base exception type. And then maybe we will just say console.writeLine ex.message. So what's going to happen now is when we run this, okay, so could not find part of the path c:/sample, a part of this path we cannot find it. It could be file name, but it could be directory name, whatever. Okay, now if you look at this one, what happened? The exception that is thrown is actually a directory not found exception. So at this line, a directory not found exception is thrown. It checks this catch block, but this catch block cannot handle a directory not found exception. It comes to the next catch block, which is of parent type, and we know that from part 21 inheritance session, we know that a parent class reference variable can point to a derived class object. And in .NET, we know that any exception directly or indirectly inherits from the base exception class. So this base exception class is the parent for all types of exceptions in .NET. So obviously this reference variable can point to any of the derived, child exception class objects. So that's how this exception class is able to catch. In fact, this is, if somebody asks you in an interview, can you tell me a practical application of inheritance? This is a practical application of inheritance. If you want to handle exceptions properly, you will have more specific exceptions on the top and the general one at the bottom, so that if there is any other exception type, we know for sure this catch block will handle that. Okay, so always remember that, have the more general one at the bottom and more specific ones on the top. Your more specific exceptions will have additional properties. For example, file not found exception has a file name property, but if you look at the base exception object, it will not have that, because this is base and very generic. All right, so points to remember: more specific exceptions on the top and the most general ones, the general exception at the bottom. But what happens if you do the other way around? If you do the other way around, you will actually get a compiler error. If you try to go ahead and build this, you will get, look at this, a previous catch clause already catches all exceptions. So obviously your general exception has to be the bottommost exception, catch block. Okay. So what is an exception? It's basically a class that derives from system.exception class. The system.exception class has several useful properties that provide valuable information. For example, the message property and the stack trace property, which gives us the call stack to the line number in the method where the actual exception occurred. And we have seen how to use the try and catch blocks, and we have also seen that we need to have the more specific ones on the top and the general one at the bottom. And there is another one called finally. Now here, if you look at this particular piece of code, this is still problematic. Why? Because if there is an exception here in this line, for example, what happens? You have the stream reader object created, and this line will never get executed because there is an exception here. So what happens? It comes to one of the catch blocks, it will catch that, and the program terminates. You are never closing the stream reader. Okay, so this line never gets executed and the resources are not released. That's why it is always important to release the resources only in the finally block. Why? Because the finally block is guaranteed to execute irrespective of whether there is an exception or not. So if there is no exception, this line gets executed, it comes to the finally block, closes the stream reader without any problems. Okay, if there is an exception, it comes either to this catch block or this catch block, finishes that, and it will still come to finally block, closes that. So irrespective of whether there is an exception or not, your finally block is guaranteed to execute. That is why you should always be releasing resources in the finally block. So let's go ahead and put this here and correct this so that we don't get an exception. And just to be sure it is coming to the finally block, let's put a message there: console.writeLine finally block. Okay, just so that we know a finally block is getting executed. Okay, so now what happens? There is no exception, so this line gets executed. Even the finally block gets executed. Close the stream reader and it will print this message finally block. So let's run this now. So you see that welcome to this, the message from the notepad, and finally block executed. which means even streamreader.close got called. Now on the other hand, let's put an exception. Let's say data1. So what happens? Data1 file does not exist. So obviously it tries to execute this line. There will be an exception. It will come here, and then uh, this catch block will handle that exception, and finally block will close that. Let's run this. Oh, there is another unhandled exception. You know why this happened? Because it came to finally block. It tried to close stream reader, but then if you look at this, the exception that we had is actually in this line. So when it tried to create that stream reader, that's when we got the exception. So stream reader will always be null. Okay, so if it is null, we can't definitely close it. That's why you need to check if stream reader not equal to null, then close that. That makes more sense. So now if we run this program, look at this. Please check if this file exists, and then finally block. So irrespective of whether there is an exception or not, your finally block is guaranteed to execute. That's why it's always a good practice to have your code to release resources in the finally block. And actually, some people might argue, okay, why do I need a finally block? Why can't I just put this piece of code? Okay, and remember, finally block is optional. It's not mandatory. So if it's not mandatory, let's do this. Okay, let's put this console.readline outside as usual. Okay, so what we are trying to do here is, instead of having this cleanup code inside a finally block, I'm putting it just outside of the catch block. So what people argue is, okay, if there is no exception, these two lines get executed, catch blocks will not be executed. It comes here, closes the stream reader. Fine, wonderful. But if there is an exception, okay, if there is a file not found exception, it comes to this, okay, it executes this catch block, and then it skips this catch block. It comes here, closes the stream reader. So why do I need a finally block? If there is an exception, it's able to close that. If there is no exception, it is still able to close that. So why do we need a finally block? Actually, the reason is, let's say for example, this piece of code here, obviously there will be some code to log the details of the exception either to the database or to send an email to the administrator. You will have some piece of code. So if this code causes an exception, it's trying to write to a database, and obviously let's say there is an exception, maybe the table is missing or some problem. What is going to happen when it throws an exception from this catch block? There is no catch block outside of this. There is no try block here. So what's going to happen? It will not execute any of these lines, and as a result, your stream reader will not be closed. That is why it is always better to have a finally block. So if there is a finally block, even if there is an exception in this catch block, it is guaranteed to execute and your resources get released. So always keep that in mind. Finally block is your, kind of safest bet to release resources properly. Okay, so we use the try, catch, and finally blocks for exception handling. And in the try block, we will have the code that can possibly cause an exception, whereas the catch block will handle the exception. And in the finally block, we'll have the code to clean and free up the resources. And finally block is optional, but make sure if you are cleaning resources, always do that in a finally block. And it's a good practice to always release resources in the finally block, which we have just discussed. And specific exceptions will be caught before their base general exceptions. So specific exception block should always be on top of the base general base exception class. Otherwise, you'll encounter a compiler error, which we have just seen. On this slide, you can find resources for ASP.NET and C# interview questions. Thank you for listening. Have a great day.